Today we are going to speak about steam distillation. And first thing we need to know the glassware we'll be using. We'll be using a 3-neck round bottom flask. 3 necks, 1, 2, 3, round bottom flask. We are going to use a vacuum adapter.
Vacuum adapter.
Yeah.
Okay.
We are going to use a condenser.
Condenser. Okay.
We are going to use a Claisen head.
Claisen head, yeah.
Claisen head, yeah. We'll need a thermometer adapter.
Thermometer adapter.
Yeah. The distilling head.
Distilling head.
Yeah.
Yep.
So you are going to need a metal O-ring.
Metal O-ring.
Yeah.
Yep.
For that you need a wire mesh.
Wire mesh.
Yeah. You are going to need 2 hoses.
2 rubber hoses.
Yeah.
Okay, cool.
And a Bunsen burner.
Bunsen burner.
Yeah.
Bunsen burner. Okay.
So now I'm going to do a... Okay.
You have the flask there?
Yeah, a flask.
On top of the mesh and the clamp. It's clamped down.
Yeah. And I put the Claisen head.
The Claisen head and
The distilling head.
and the distilling head. They're on the middle neck, yeah?
Yeah. But I need... This one is called a neoprene adapter.
Yeah.
No, not neoprene adapter.
Keck clip?
No, a plastic joint clip. Plastic joint clip.
A plastic joint clip.
Yeah.
Alright,
So
it's all
now
stable.
you need yeah. So this one.
Be careful here.
Yeah. Our condenser wire in at the bottom.
Plug in the condenser at the bottom.
Wire in at the bottom. And out from the top. Wire in at the bottom, out from the top.
So you plug the water in, the water will be going in from the bottom and out through the top.
Yeah. And you still need a plastic joint clip.
Another clip. You gotta be, if you don't have this, it'll fall off.
No, I know. So
It's just
no,
kind of
we
stable.
need a stabilize that.
Another clip. Another clamp.
Yeah.
Yeah. Gotta be careful.
Okay. Stable.
Nice and secure.
Yeah.
So this is pretty stable.
Yeah, but
This
it
is
is
pretty
going to stabilize.
stable. So this clip down, and so it's not going to fall over.
Yeah.
And you have water that's going to come in from the bottom. Out.
Not
Very
water.
careful.
That's the first thing you do.
Gently.
Yeah.
Just a little bit of water. Just a little bit. So it's
Okay.
circulating now. The water is circulating.
Yeah. In at the bottom.
Out the top. We see the water
See water here.
flowing out the top. Alright, so there we go. There's the basic setup and all. Alright, so we just added the separatory funnel.
Yeah, and you make sure that this one is outside.
With the little joint
Not
outside,
like that,
yeah,
but like that.
so that you can control it on the outside.
Yes.
and it's there. And then you got the distilling head, I guess, or whatever that's called.
That's a vacuum adapter.
Vacuum adapter.
Distilling head is.
Distilling head's there. Okay.
Yeah. Now here is a thermometer adapter.
Thermometer adapter, like you used last week.
Yeah.
Thermometer adapter and the thermometer. And that's going to go up top in the middle. So just the right distance so that the blue part of the thermometer is right there, right?
Yeah.
So that the thermometer reading is going to be right there, which is where the vapors are going to climb up and then condense through the condenser. Flip it down for security.
Okay.
Alright, so that's the full apparatus, yeah?
Yeah, I just need to close here.
You're plugging the third hole?
Yeah.
Okay, you're plugging the third hole. Alright, cool. Let's go.
So we will need 7 grams of cloves, you see here inside.
So you're going to weigh out 7 grams of this clove stuff,
Yeah.
which you're going to be steam distilling.
Yeah.
Yeah, okay, cool. So you got your little weighing boat.
Weighing boat, yeah.
And a spatula. And
Actually, that's the spatula.
The big spatula.
Yeah.
Not the small one, because it's 7 grams is a lot.
Yeah.
All right.
Yeah, I can even go with hands.
Yeah, just use your hands. That's 1.6 grams.
7 more.
5.1. 6.2. 6.7. 6.8.
Almost there, huh?
Almost there. 6.9.
Just one.
One little one. And we're basically there.
Yeah.
Close enough.
Yeah.
7.01 grams. 7.01 grams.
Yes, this means 7 grams.
Yeah. Basically 7 grams.
Back to 0. Okay. So, no mortar and a pestle to grind that.
Okay, so you're putting the cloves in a mortar, and you use a mortar and pestle to smush it up,
Yes.
to grind it.
Yeah. Grind that up.
Kind of like pulverize it into a semi-powdery
Yeah.
mixture.
So we're going to need 150 milliliters of water.
You're going to get 250 milliliters of water?
No, 150.
150. 150 milliliters of water.
But
Alright, so you have 150 milliliters of water
yeah.
and in a beaker.
Yeah. So first I'm going to add
You have a funnel.
the plastic funnel, and I'm going to add protein.
Carefully pouring it through. Hopefully it doesn't clog the funnel.
Yeah.
It doesn't look like it is.
Okay.
Alright, the cloves are in the flask.
Yeah.
You're going to wash it over.
Some water. Not a problem.
Alright, so most of it's washed over. And then just
And
pour
the rest
150 mils total of water. All right.
Now the next step, I'm going to add some water here.
Now you can add some water into the separatory
you
funnel.
need to use the separatory funnel with a big tip.
With the ground glass joint.
Yeah.
Because otherwise it wouldn't attach.
Yeah.
So with that kind, because some of them
one,
don't have that. Yeah.
Usually it's funny. This one here is called the male glass joint, and that's the female glass joint.
Female one. So you have the male joint,
Male,
the female,
yes,
yeah.
And the female
Ground
is here.
glass, yeah. Got it. All right. All right. So you added just a roughly 3/4 full.
Yeah.
Water. You didn't measure that. You
No.
just poured it in.
Yeah.
And it's closed.
Yeah.
If it wasn't closed, that would be a mess.
Yes.
You close the valve, put some water in there. Okay. Now you
Let's say this one. And you know, when you distill, it's always boiling, vaporizing, condensing.
yeah.
When you boil the water, the amount of water is going to decrease.
The water will
And you can
decrease.
add
Yeah.
from here.
So as it's boiling away, you can add more water.
Yeah.
Got it. So that's why you have that second thing on the top.
Yes, absolutely.
For steam distillation. Okay.
So now, still have, you need a 125 gallon flask, which you put here, and you can see here it doesn't have a top, but that's not a problem. You just need to use the jack, bring the jack up.
So that's 125 milliliter Erlenmeyer flask.
Yeah.
Cool. To capture the material as it distills over.
Okay. So now, the next step, you need to use a Bunsen burner.
Yep, so you're attaching the Bunsen burner to the
Gas.
gas. The
The
blue
gas.
the
Blue is
blue
only
one's
the
the
gas.
gas. What's the yellow one? Is that air?
The yellow, that's the vacuum,
Vacuum.
and orange, that's air.
Air. So we don't want those. We want the blue, which is the natural gas.
Yeah.
All right. So you're gonna give it a little bit of gas
Yeah.
first.
Yeah.
You gotta be careful.
Very careful.
Very gentle. Give it a little.
So here is the Bunsen burner. Okay. I turn the gas on.
Turn the gas on.
On.
Yep.
Bunsen burner is on.
Yep.
Put that here at the bottom. And we start with heating.
So
We are
we're
going to collect the cold distillate here.
yeah. You can make sure everything is nice and secure.
Yeah.
We got the clamps.
Yeah.
Are pretty good. It's a little maybe tighten it a bit. Okay, cool. So there we go. We're cooking at a high temperature with the Bunsen burner.
Yeah.
Okay, so cool. All right, so we're a couple minutes in. It's heating up. The metal's getting really hot there.
Yeah. We're going to boil. Water is condensed,
Yeah.
and we are going to collect over there.
We see some bubbles, so yeah, it's getting there. I'm gonna stick my hand in the fire and see how hot it is.
It's hot. Don't do that.
No, no,
Leave
no.
your fingers. It's really hot.
That's what the red means.
Yeah.
And then once it starts boiling, you're gonna add a little more water, right?
Not right away.
Not immediately.
Yeah, yeah.
Okay.
Because once water starts to boil, then as you know, when you distill, boiling, vaporizing,
Yeah.
condensing, collecting here, once it vaporizes, so the amount of water is going to decrease.
Yeah. Yeah.
And then if it does decrease, you can add water from here.
You add more water. Okay, cool. All right. Okay, so we're continuing to go forward in the experiment. The the one thing we changed is we added an ice bath around the receiving flask.
Yes.
Which will keep it cold
Yes.
after it condenses through the condenser and down into the vacuum adapter. Yeah, just to make sure it's collected nicely. All right, and it's still hot and starting to boil, but we need some more time. We need a little more time. But there's the cloves at the bottom. We see some bubbles. All right. All right. A couple of minutes later, it's got a nice, intense boil, and the vapors are coming up, and you can actually see that the vapors are reaching up to the thermometer adapter. And we're starting to see the water and clove materials drip out, so we're capturing the product there.
You see it's starting to come?
Yeah, it's coming.
Yeah.
See some drips, some drips.
Good, yeah.
Looks pretty cool.
Yeah. I'm going to collect until 75.
And what's your temperature? It's coming off at about 100 degrees, which makes sense because the water boils at 100 degrees.
Yes. It's, yeah.
A 95-ish.
95, yeah. Yeah, it's coming, it's good.
And the clove materials, was carbone or what's the chemical? The eugenol.
Eugenol.
Eugenol, that's
Yeah.
the chemical. It's coming out through the condenser, the cold surface of the condenser. The condenser's cold, of course, from the water. Water's coming in, coming up, and coming down. And it looks pretty cool, like it's working. So that's eugenol, that's the molecule that's being
This is going to isolate. That's the molecule. Yeah.
isolated from steam distillation of the cloves.
Yes.
And the students should know what the functional group names are for that.
Yes. I think you have already done that.
We did that in
Okay.
class. And they should also know what the functional group name of this is.
Yeah.
They should also know what the
They should know all the
name.
functional group of eugenol.
Yep, and what the ring is called, and also what this weird thing is over here. They should know about all that stuff.
Yeah.
Okay.
It's written very well. See, collection here.
Experiment's proceeding, it's still boiling, it's still going up.
We're going to collect 75 milliliters of co-distillate, because what you have here is a co-distillate.
Yeah. There's a co-distillate of water and eugenol, yeah?
Eugenol, yeah.
Yeah. What's the temperature at now?
96.
96. Cool. It doesn't really go higher than that. It maxes out at 100. Well, about 100.
Yeah.
Okay. So how much are you collecting total?
I'm going to collect 75 milliliters.
75. And so you got a ways to go.
Yeah.
And then meanwhile, here and there, you'll add more water. You'll add
and to add more water, I will do that.
Gently pour a little bit of water in.
And I close that again.
Yep. Cool.
If this one had been over here, I had it possible because it had been too hot.
Yeah.
That's why you did that.
Oh yeah. So that's why you have the nozzle or the valve on the left.
Yeah.
Because otherwise you're gonna burn yourself on the hot glass.
Yeah.
Yeah. That makes sense. All right.
Now,
So we're gonna
it goes again.
keep going and keep collecting for a total of 75 mils. We're at about 30 now or so.
Yeah.
All right. Cool. So we'll come back in a few minutes.
Okay. So I need to speak about boiling points here. Eugenol has a boiling point of 250 degrees Celsius. 250, you see that it's very high. Water has a boiling point of 100 degrees Celsius. When you do a steam distillation, okay, you are going to collect your cold distillate at a temperature lower than 100 degrees Celsius. In our case here, you are collecting the cold distillate at 95 degrees Celsius.
That's cool. So you're getting something that's really high boiling to come off at a lower boiling point.
And you do that to avoid the decomposition of eugenol.
Because at the boiling point, it might actually decompose itself.
Yes.
And so you're getting away with a really low temperature.
Yes.
The boiling point of the co-distillate, roughly 95 degrees Celsius.
Yeah.
Cool. Other fun thing is we actually have a IR thermometer.
Yeah.
And so I can measure the temperature on the glass. So let's shoot that.
Yeah.
And let's see. So it's pretty, let's see, it's actually, we're at about, it's actually, we got it about 500 degrees Celsius. It actually shut off the scale, so somewhere about maybe 600 degrees Celsius, right there at the hot point. It's too hot to measure with the thermometer.
Yeah.
Okay.
So now we did collect 75 milliliters of cold distillate.
So that was your target, right? 75?
75 milliliters.
There it is, 75.
Cold distillate. The first thing you do is to turn off the gas.
Turn off the gas.
Yeah, that's the first thing to do. You leave the water on, it has to cool down before doing.
And the big flask's got to cool down too.
Yeah.
Yeah.
So you can bring that down so no problem.
But turn off the gas first.
Yeah, so you need to turn off the gas as I did.
Right, so there's your product.
And I will take that here.
Kind of a milky white solution. Still dripping a little bit, but that's okay. Okay.
So you need a 25 milliliter round bottom flask.
25 ml round bottom flask.
That has to be cleaned and tear. That means that you need to take the weight of an empty round bottom flask.
So you can clean it and then get the weight. It's already
and
clean.
It's easy, you just put that on the balance like that because it's already at zero.
Okay, so it's 42.590.
Yeah.
42.590.
Yeah, how you go like that. 40.
42.590. It's the tare weight, the zero weight.
Now, I put that back here. I have that, and you go to the hood. I need to give some explanation. So the solvent you are going to use to extract the eugenol from this solution here will be methylene chloride.
Methylene chloride, which is CH2Cl2. It's also called dichloromethane. Dichloromethane.
So, but you need to do that in the hood. We are not authorized to do this step at our benches.
Because it's a carcinogen, right?
It's carcinogen,
Yeah. It'll give you cancer, so you have to work within the hood to avoid the toxicity.
Yes.
So this step must be done in the fume hood.
Yeah.
Okay.
The first thing, you have this separatory funnel.
Use separatory funnel.
Yeah, but you need to check if it is not leaking.
And make sure it's not leaking.
Yeah. The way you do that is very easy. You open the water.
Put a little bit of water in there.
Put water in there, and you see. That's it.
That it's not leaking.
Not
Good. And this is the other kind of separatory funnel without the ground glass joint. It's just a little tube at the bottom.
Yeah.
So in the distillation, you use the ground joint.
Yes. You take your co-distillate.
Okay, so you're pouring the co-distillate into the separatory funnel.
Yeah.
So this is a mixture of water and eugenol.
Yeah. So now you know that eugenol is an organic compound. Okay. To extract eugenol from this mixture here, you will need an organic solvent. And as I said, the organic solvent you are going to use is methylene chloride. I'm going to do 2 extractions each time with 10 milliliters of methylene chloride.
So 10 and 10 is 20 total.
Yeah. So
Do you have a graduated cylinder?
I have a small beaker, labeled methylene chloride, ch234.
Little beaker.
Yeah. I add methylene chloride into the small beaker.
So 10 mils, roughly.
Yeah. I close it. Graduate cylinder, and I add 10 milliliters in.
Measure 10 mils.
Yeah.
There's your 10 mils. Oh, I think there's a dead mosquito in there, but that's okay.
Yeah. I did not send him there.
Okay, so we have a mosquito in the mix.
Yeah.
But
So
that'll be a contaminant of your product. And they know the density and that the methylene chloride's in the bottom, right?
Yeah. Like that. When you do that, you also have helmet.
Get out of the way so it doesn't shoot at me.
Yeah. I'm not going to do that. Put that back here. Okay? So now, you have here 2 layers. You have the top layer and the bottom layer. So, to know what layer is the top layer and what layer is the bottom layer, you need to know the density of the 2 compounds. In this case, you see that the organic layer, which is basically the methylene chloride layer, is the bottom layer. And the top layer is the aqueous layer. So, the organic layer, in our case the methylene chloride layer, is the bottom layer because methylene chloride has a density higher than the density of water.
Yep.
The compound with a lower density will be the top layer, and the compound with a higher density will be the bottom layer.
So the water's 1.0, and methylene chloride is like 1.2, I think.
Something like that, yes.
Yeah. So the water's on top because it's less dense.
Yes.
The methylene chloride is on the bottom because it's more dense. And you can look up those numbers on the internet, I think, the densities.
Now, I am going to do a first extraction. It's very important so that when you extract, okay, you need to turn the top. And extract.
Draining out the bottom into a flask. Okay, stop.
Stop. That's the first extraction.
So there's your the product in the dichloromethane from the first extraction.
Okay. Now,
And the thing you were saying is you pull the top out because otherwise it creates a vacuum.
Yes.
Right. That's a classic mistake. Everybody, the first time you do this, you forget to do that, and then it doesn't drain out the bottom because you're clogged at the top.
yeah.
So good thing you didn't make that mistake.
No. So I'm going to add.
That's your second extraction of dichloromethane.
Second extraction. 10 minutes of dichloromethane.
Alright.
And a little more. You're teaching at 5?
No.
Okay. Because I gave a student off this week. Okay. Now we are going to do the second extraction.
Second extraction.
Here. Go. Shake it. You can also air vent from the top. No problem.
Yeah. I like that because if you vent from the bottom, sometimes you shoot people accidentally.
Yeah.
If there's a neighboring person, you might
Right.
shoot them.
Yeah. It's better.
Sometimes it squirts out the bottom, but
Yeah.
if you vent from the top, it
From
doesn't
the top
squirt
is
out.
good, yeah.
Yeah, that's good.
That's that. And you can see the two layers, and I repeat. Okay. The organic layer is the bottom layer because natrium chloride has a higher density than the density of water. And as things you should know of the exam. As things you should know in OChem 1, but also in OChem 2.
Yeah. Do you know any solvents where the organic layer is less dense? We know methylene chloride is more dense, but like, I think
Yeah, we have an experiment
coming up.
where, it
Yeah,
could be the opposite.
I think the general rule is if it's chlorinated, it's always on the bottom. And if it's not chlorinated, it's almost always on the top.
Yes.
So like ether,
Yeah.
hexane.
Because we have
those are on the
one
top.
with ethyl acetate.
Ethyl acetate
water.
on the top. Yeah. Yeah, it's a good general rule.
So now I do second extraction.
And the cap's off. Yep.
Yeah, absolutely.
Stuff.
Okay. So here is your organic layer containing your eugenol.
Yep.
But your organic layer is still wet. Don't forget, you have done 2 extraction, okay, with water here.
Yep. So there's a little bit of water in there.
You still have some water left over here. In order to remove this amount of water, this leftover water, I call it like that, I'm going to use a drying agent. The drying agent which was made available to me was magnesium sulfate anhydrous.
So it's magnesium sulfate anhydrous. It's MgSO4.
Yeah.
And anhydrous means it's a special crystalline version that does not have water, so it's anhydrous. There's no water.
Yeah.
Right.
So what I do?
Because they also have magnesium sulfate that has water, and that would be bad.
They call that
hydrate.
Hydrate one, yeah.
Magnesium sulfate hydrate.
Yeah. We use that for some experiment.
Sometimes,
So,
yeah.
I'm going to add 2 scoops of drying agent. That's the drying agent that has to be closed. You need to close the drying agent container.
If you don't close it, something is going to get inside,
Yeah.
like water. So now the magnesium sulfate is sort of
Going to water.
swirling around in there, and it's soaking up water. to dry the dichloromethane, methylene chloride. Okay.
The next step will be what is called a gravity filtration. We need a glass funnel, a folded filter paper, that,
Into your destination flask,
yeah.
the final one. Gravity
And
filtration.
I put the flask
Yep.
into a beaker. Okay. That's to avoid what I call technical mistakes. And
You just filtered out the magnesium sulfate into the
Yeah.
paper.
yeah,
Now the product is there with no salt,
yeah,
no magnesium in there,
and no water.
and no water. The water should have be left with the magnesium in the paper. Cool.
So now I just close that. I should not be inhaling the
Methylene chloride.
methylene chloride. Now you have here your organic layer, your dry organic layer, in our case the methylene chloride layer containing eugenol. The next step will be the rotary evaporation.
So the rotary evaporation is a way to remove the dichloromethane or methylene
Yeah,
chloride
to evaporate the solvent.
and then leave your good stuff behind,
Yes.
your product.
That's dry ice.
Okay, so you're adding dry ice. This is the rotary evaporator.
That's the rotary evaporator.
And it's just got a water bath and a flask.
A
And then
condenser.
is that a, what kind of, is that isopropyl alcohol or
That's isopropyl alcohol,
isopropyl alcohol
which is also called 2-propanol.
or isopropanol?
Yeah.
And so you added the dry ice, and that'll cool down the surface in the middle.
Yeah.
There's
Here's the vacuum pump.
internal surface.
Yeah.
And you have a vacuum pump. Cool.
Here is the bump trap.
Bump trap, which
Yeah, that's it.
catches the bumps.
Yeah.
So if it splashes from your flask, it catches that.
Yeah. And you need to turn that on here.
Let's see. Okay, switch going on.
Turn that on. I say you only have to make sure that the round bottom flask you are going to use has a female glass joint that fit to the male glass joint of a bump trap.
Yep. Doesn't fit, then
You're not going to,
it won't work.
yeah. And you need a plastic joint clip, as you see here. Yeah. Now you lower
She lowered it in.
Yeah,
You pushed that little black thing, and that allowed you to move it up and down.
yes, yeah.
Okay.
Start rotation. Then you turn on the vacuum.
I think you're watching the pressure, right?
Yeah. The pressure has to decrease.
Pressure has to decrease.
Yeah. You don't need to use the heating here because that's methylene chloride. And methylene chloride has a low boiling point. The boiling point of methylene chloride is 40 degrees Celsius.
Okay. Yeah, that's a low boiling.
Yeah.
So you
But I can but just like that.
so you don't need temperature. You don't need to add a warm temperature because if you do, it might bump
Yeah.
to the bump trap.
Yeah.
Yeah.
You see, I turned that on here, but I just kept that at 30 degrees here. At
So
the bottom.
just keep it a relatively low temperature.
Yeah.
Yeah. Okay. So water bath. And now what's happening to your? Where's the solvent going? It's
All the solvents go here to the receiving flask.
well, but it's boiling out of here. It's actually it's boiling out of here, and as a vapor it comes
And
up,
start
up,
to
up,
drip. See?
comes through, and then it touches the dry ice,
Yeah.
and then it drips into the receiving flask. And do we see any yet?
Yeah. And I can check.
Yeah, there we go.
The
You see
pressure
the-
has to decrease.
See the dripping?
Okay. And I can check by looking at the pressure here. At this pressure, that has to come out, and it's coming out.
At about 400 bar, I think.
Yeah,
400
millibar.
millibar.
Yeah.
400 millibar is like the perfect number for methylene chloride.
Yes.
And so you can see that it's getting concentrated. There's less liquid.
Stop the rotation.
Okay, so it's done.
Done. You stop the rotation.
We stop the rotation.
Okay.
Turn off the water bath.
So you don't forget to turn off here.
Turn off the switch.
You stop
Turn off the pump.
and you release the pressure. You release the pressure.
There's a vacuum.
Yeah.
So
Because if you don't release, you won't
Yeah.
be able. You're not going to be able to take
Yeah.
the flask. So
Because the
now,
vacuum would hold it on.
take that. And here is the original.
Cool.
That's
It's
the
your
bottom.
final product, kind of a liquidy,
The
eugenol,
little yellow.
little yellow.
Yeah. So, yeah, whenever you are done with your evaporation, you also need to clean. Then you take off the receiving flask. You get a beaker.
So that's the dichloromethane, methylene chloride. Waste.
So, that's the receiving flask. You empty the receiving flask. Take some acetone. You rinse the receiving flask with acetone. Do
Acetone.
that twice.
Yeah.
Okay, now it's clean. Then put it back. Now you have to take off the bump trap. Rinse that with acetone.
Cleaning the bump trap.
Yeah. You do that twice. Then you put it back.
And it clips in, yeah, with this little,
Yeah,
this thing.
yeah.
This thing clips and holds it on, basically. Yeah, good. Right.
So these instruments are expensive. In the past, students did evaporate with solvent at the benches, and that was not good. And since a couple years, so we have a rotary evaporator.
So we have like 4 or 5, about 6 of these, or
6 in each lab, 2 in each lab.
2 in each lab.
Yeah.
So yeah, they're about what, $10,000 each or something.
Yeah,
A lot
They're
of
expensive.
money. Pretty expensive.
Yeah,
It's an essential piece of equipment
yeah.
in organic chemistry. Yeah.
$10,000 each one.
Or maybe 15,000. A little more.
Yeah. So the way of taking weight, I use the no pin adapter.
So you get a weigh your round bottom flask with a product. So you
bring
use the neoprene adapter and you zero.
bring that to 0.
So now it's zeroed. And you put your flask on top. Now you have the final weight. 42.808.
Yeah.
42.808.
Yeah.
Cool.
Bring that back to 0. You need to put that back. You need to close it.
Cool.
42.808.
42.808.
Let me correct. That means 32.808 minus 42.590. So 0.2.
So your final number, you do that math, that's 0.208 or 208 milligrams.
Yeah.
So or 0.2 grams.
Yeah.
Cool.
Of regional.
Final product, so that's their yield, I guess.
Yeah. Cool.
Alright.
So now, the next part, I'm going to show you how to reconnect that.
Disconnect everything?
Yeah. You can see it.
Really careful, everything's expensive.
Yeah. Take that out.
Separatory funnel with the water.
Yep.
Is your water off? You turning the water off?
I will. Can do that now. Yeah, it's off.
Water's off. Drain out all the water.
Yeah. I'll go over here.
A little bit of a mess we'll clean up.
Yeah. Make sure that the hose is not there. Yeah. Now, this one here.
It's just the clove and the water mass, or waste.
Go to the vacuum.
Okay.
You don't have all of that. What you do, you have some water.
Alright, so there's the kind of solid waste from the cloves, and there's a little bit of water on the bottom. Black water. Kind of rinsing it all out.
Okay.
Whoa.
Clean. No?
I'm worried the vacuum is going to suck the stuff out. So you have to be, yeah. The foam almost got sucked in, so I turned on the vacuum.
And here. And this here, that goes to, I'm going to put it here like that. Usually if you don't put leave that here, that's not good.
this like a solid waste?
No, it's a container for that.
Yeah.
I just put that in the hood. And we're going to collect that.
They'll collect that solid waste?
Yeah.
Okay, it's like a clove, the leftover clove waste. Okay, cool.
This is one.
Yep.
This is one, but you don't have an inorganic waste bottle here.
So normally it would go to a water waste, aqueous
Yeah,
waste. Okay, cool. That's it?
That's it.
That's it? Alright.
Interesting one, eh?
Yeah, it's fun.
Yeah.